You're listening to Interactive Media for the Performing Arts, a lecture by Dr. Liza Seigido, composer, multimedia artist, and founder of Seigido Electroacoustic Opera Company. This lecture was brought to you by CMNarts.org. Hello everyone, my name is Dr. Liza Seigido. I am a composer, multimedia artist that specializes in electroacoustic composition and interactive media. I've been producing work in this vein since 2007. Rather than read off my CV, I invite you to visit my YouTube channel, which is accessible through my website, lizaseigido.com, if you're interested in checking out my work. I also encourage you to visit my electronic opera company's website, psycheopera.com, for information about my latest projects and productions. The performing arts has been moving towards performer-audience environmental interactivity since the coining of the word Gesamtkunstwerk. And with the advent of consumer VR and AR technologies, it will be difficult for artists and producers of live performances to ignore these technologies if they want to draw audiences to their work and stay relevant moving forward. On Wednesday, whilst preparing this lecture, I was notified of Opera America's Opera Hack project. This upcoming week, starting on the 26th, Opera America is hosting a webinar about its Opera Hack project, whose mission is to, quote, discover new methods for technology to be used in the production and presentation of music theater. This is precisely what I and many electroacoustic composers have been doing for years, and I'm happy to see large companies discovering these new tools because that means more opportunity for those of us who learn to use these tools. However, this isn't why I picked up interactive multimedia technology as a compositional tool in graduate school, and this isn't why it matters to me. I was purely an acoustic composer when I started graduate school. I wasn't interested in audiovisual technology nor tinkering with electronics at all, and I was perfectly happy to write my string quartets and ignore what my electroacoustic colleagues were doing. Then during a conference, I witnessed my first electronic opera, which was written by Alison Warren, and I realized how creators like myself could expand the expressive scope of our concert pieces and stage works through technology. I was intrigued by tech for the first time, but I didn't cross the point of no return until I began experimenting with Max MSP. I fell in love with this tool in the same way that many of my composition teachers fell in love with Vellum. The tool itself inspired me and expanded the scope of my artistic output. So mainly, this is going to be a very self-indulgent lecture with me talking about the tools that inspire me to create. However, at the same time, I hope that my spiel will be informative and will leave you with a head bursting with ideas and with practical starting points on how to actualize them. Now, it's difficult to talk about my tools without first talking about how they've changed the way that I compose concert pieces and stage works. For me, composition has merged with a design process called physical computing, where one uses electronics, mainly software, to produce an experience for an audience. My process of composition and physical computing has roughly 5 stages. Stage 1, define the experience you want to create. I try to get as specific as possible during the pre-composition process and create a timeline for my stage work that describes the music, lighting, and scenography and how performers and/or the audience will interact with those elements. Most of my recent stage works involve a libretto or text, and it helps to have a libretto, rough story arc, or timeline in hand before you generate any musical material or commit to any technology for your piece. I consider composing the fixed element of my work as stage 1B. This is where I generate all the predetermined musical material for my performers and create a score, which will also serve as a detailed timeline for planning out the scenography, lighting design, and reactive or interactive elements of the composition. Scores are especially useful if you're working with dancers and choreographers. I sometimes have a stage 1C where I generate a fixed version of the composition in the form of a recording or video. This has helped me refine a score, define my technological needs, and is extremely useful to performers for reading and/or workshop preparations. Stage 2, select sensors and actuators that will prompt the desired interaction between humans, your performers and audience members, and the reactive or interactive elements of your composition. I'm going to use my latest opera, Cyborgs Are Dancing, to talk about this stage and next stages. Cyborgs is presented as an ordinary opera with designated performance area and audience seating area. However, the audience, via a wireless gaming controller that's passed around, can participate in the music making and manipulate the lighting and scenography, thus co-creating the composition with me and the performers on stage. The performers on stage are processed in real time, and the dancers triggering sounds with her movements. Although the piece has consistent, recognizable elements, it will be different every time it's performed due to the impromptu contributions of the audience and the random elements introduced by the performers on stage and the program used to process their sounds or translate their movements into sound. Here are some clips from Cyborgs Are Dancing's workshop. To make this piece a reality, I needed the following sensors: microphones to capture the performance of my musicians, two webcams to capture the movements of my performers on stage and to incorporate a live video feed component to my scenography. The wireless gaming controller has two types of sensors, temporary switches and potentiometers, that the audience can interact with. In the future, however, I plan to expand audience interaction with a cost-effective solution that would allow me to involve every single audience member. I'm communicating with a software developer to realize the solution, but that's all I'm willing to say about this top secret project for now. Actuators output the programmed behaviors of your piece. Speakers, projectors, computer screens, LEDs, motors, servos, and solenoids are all examples of actuators. Cyborgs Are Dancing utilizes a stereo speaker system, a small DMX lighting system, and a high lumens projector. Now, stage 3 is when things start to get tricky. And if one assumes certain options will work for one without carrying out the proper research, one will end up with technological flop or unnecessary purchases. Select sensor interfaces that are compatible with your sensors and with the software you're going to use to program the behaviors of your interactive system. In my work, I research sensor interfaces that are compatible with Max 8. Many sensor interfaces have built-in microcontrollers that are pre-programmed to work with specific types of sensors and format the output of those sensors using digital communication standards such as ASCII, HID, OSC, DMX512, and MIDI. Arduino sensor interfaces are the most flexible on the market. But if you are not an engineer experienced in circuit design and coding with processing, then you will need to research existing circuit schematics with compatible processing sketches for your project. Max is pretty flexible in that it natively reads ASCII, HID, and MIDI devices that plug into a computer via USB connection. So let's finally talk about the dark side of the force. Max 8, a graphic object-oriented programming interface, is the go-to software for many visual artists and electroacoustic composers and installation builders. I've worked with Max for over 10 years in the realm of interactive computer music and installation building. It's an approachable yet powerful programming language. When you decide to use Max 8 to program the behaviors of your build, you simultaneously limit your sensor interface, and actuator options at the onset of your project, which reduces the complexity of your build and saves you time. As mentioned before, Max natively reads USB audio interfaces and webcams, plus ASCII, HID, and MIDI sensor interfaces devices with USB outputs. With third-party software, Max can also work with OSC, DMX512, Arduino, and Fidgets devices. In as far as actuators are concerned, Max can send signals to powered speakers using audio interfaces and video to projectors and other types of displays using the built-in digital video outputs of your computer. You will need to use Arduino or Fidget sensor interfaces with specialized outputs to work with actuators like LEDs, motors, servos, and solenoids. Remember that these sensor interfaces require third-party software to communicate with Max. Stage 4. You're ready to program the behaviors of your interactive system, and in my opinion, Max 8 is an ideal piece of software for programming interactivity between audiovisual and lighting elements of your composition. Now, before we move on to stage 5, it's important to know that creating an application that's processing digital audio and live video feeds in Max require that you have a powerful computer. You can get the most bang for your buck with a basic gaming PC, desktop, or laptop. Stage 5. Validate your interactive system. Run your system in the environment it will be used. Validation may require hours of troubleshooting. Once your system works as intended consistently 3 or more times in a row, then your work is ready for an audience. It isn't always obvious why a venue change or a small change to your computer, like software update, would adversely affect your system. Just know that it can. It's happened to me plenty of times. You need substantial tech time in the venue to troubleshoot problems that are specific to that venue. Also, you must never tweak your system before or on performance day and delay all software updates, even if they are unrelated to your project, until the performance day is over. Here are some clips from Cyborg's Tech Week that show parts of my validation process. Okay. Now this little controller not only creates music, but as you can see, it also affects the saturation of the mapped video overlay. Let's see if I can... So here are some steps and resources that can help you begin experimenting in this realm. And to clarify, I'm coming at this from the perspective of a musician. Everything I list here can be used without an engineering background. Step 1, learn Max 8. It's absolutely more approachable than its sister Pure Data and other 4GLs that are out there. You can download a free trial on cycling74.com and begin by building small applications. I've produced a ton of free Max tutorials and they're available right now on my company's YouTube channel, which is accessible via psycheopera.com. I'm also working on a Udemy course for Mac. I'll announce the launch on our Instagram and mailing list, so please follow or subscribe. Links are available on psycheopera.com. Cycling74 also provides a list of online Max educators on their website, so check those resources out as well. Regarding books, I highly recommend that you check out Composing Interactive Music by Todd Winkler for learning how to build MIDI-based patches in Max, and Electronic Music and Sound Design by Alessandro Cipriani and Maurizio Chiri for sound synthesis techniques in Max. No, I'm not being sponsored by anyone. I just use these resources and I can attest to their awesomeness. For learning more about real-time video processing and/or creating generative video in Max, search cycling74.com for jitter recipes and reverse engineer those patches. Step 2, familiarize yourself with the most useful sensor interfaces and microcontrollers on the market. 1, Arduino and its offshoots like the Makey Makey and the Vilrose Fun Force. 2, check out fidget sensor interfaces. 3, experiment with simple hacks involving a computer keyboard or gaming controller. 4, check out Dentaku's Ototo. 5, check out Bear Conductive's conductive paint sensor interfaces. 6, definitely check out the awesome wearable electronic kits by Adafruit. Researching these tools will lead you to more resources. For those of you who want to get into interactive lighting design and special effects, please check out DMXs by Entech. It's a software-based DMX operator that you can host in Max or any DAW as a VST. The software comes with a USB DMX interface. I've used DMXs for years. It's awesome. Reminder, you can control more than just lighting with a DMX operator. Nowadays, there are DMX smoke machines, laser fixtures, pyrotechnic systems, etc. Okay, so this is the end of my spiel. I hope you found it informative and useful. I'd be happy to take questions via email. Feel free to contact me through the contacts page at psycheopera.com. Thanks for watching. I'll see you in the next lecture.